So our next group of rocks, sedimentary rocks, are the biochemical sedimentary rocks. And as you can kind of tell from the name, the bio part means we're going to have living organisms involved with making these. So most of this is all sediment that's derived from the shells of the living organisms, whether the shells are incorporated as fossils or it's incorporated as an ooze that'll hold the glue together. But what we're doing is we're incorporating life in here. Most of the shells of these organisms is going to be made up of either calcite and aragonite, which calcite you should recognize. That was a mineral we looked at on Mohs hardness scale. Or silica, basically microcrystalline quartz, as you can see here, SiO2. So let's take a look at each of these. So limestone is definitely my favorite biochemical sedimentary rock. It's made up of calcite, and again, if you remember from the mineral chapter, the way I can test this is putting a little bit of hydrochloric acid on there, and it would fizz, right, like crazy. But the coolest part about limestone is it is full of fossils, as you can see here. And the reason why limestone is full of fossils is because of where limestone gets deposited, where it forms. So limestone, anytime I see limestone, I want you to remember this, limestone equals a coral reef. So limestone develops where coral reefs are. Okay. So if you think about that, where do we get coral reefs? Well, coral reefs are pretty specific. You can't just get them anywhere. We don't get them here in the southeastern corner of Louisiana. But what we have to have in order to have a coral reef, it's got to be warm tropical water, right? So near the equator. It's got to be pretty shallow to let light in. It's also got to be clear to let light in. Got to have lots of oxygen, and it's got to be salt water. We don't really have any freshwater corals today. We used to have them way back before humans were around, early on in Earth's evolution, but we don't have them anymore. But the water's got to be warm and tropical, got to let lots of sunlight in, because the algae that lives with the coral is photosynthetic. So it's pretty specific. And of course, as you can even see in this picture down here, that if you're in a coral reef, there's lots of life. There's lots of fish, there's lots of oysters, there's lots of mussels, there's lots of life there. So you can see why we get lots of fossils. But what's really neat, like I said, is limestone tells us about the environment. So where I grew up in Illinois, there is limestone everywhere, just absolutely everywhere. Most of the houses are made of limestone. So that definitely tells me that the Chicagoland area of Illinois, right, 300 million years ago, was underwater. And it was near the equator, right? So totally different than it is today. And that's what I really, really love about these sedimentary rocks, is they really give us a lot of extra information. We can also get chert. Chert is another very common biochemical sedimentary rock, and this is made up of cryptocrystalline or microcrystalline quartz. And so what happens here with chert is we have little organisms that have shells, and their shells might be made up of quartz, and their dead body will float down to the bottom of the ocean floor, and it will start to dissolve in the water. However, quartz doesn't really dissolve in water very well like salt does in water. Under pressure, it'll dissolve a little bit better. But basically, it's going to separate like oil and water does. You've got a very heavy, dense water that sits at the bottom. It's going to form an ooze. I really just like saying that word. It's going to form this ooze. And if that ooze compresses and forms a rock, it forms chert. Right? So anywhere we see chert, that tells me that was generally in the very deepest part of an ocean, under an immense amount of pressures. All right. And then our next type of sedimentary rock, we've only got one slide for this. This is our organic sedimentary rock. Organic sedimentary rocks are made up of organic carbon. So we really only have one true rock that fits in this category, and that's going to be coal. Oil fits in here too, but oil is a liquid, so it's not really a rock. We'll talk about that in a second. But coal is just compressed plant matter. So coal develops where we have swamps. So in a swamp, there's not a lot of oxygen turnover, so that material just kind of sits down at the bottom of the swamp water and collecting. Over time, it will compress and form a rock, right? And that rock is is coal. And we have different stages of it, going from least compressed, right, peat, to slightly more compressed lignite, more compressed bituminous, and then it'll reach into the metamorphic stage, anthracosite. Oil is also organic because oil is made up of the compression of lots of microorganisms over time. But remember, right, oil is really a liquid, so not quite